Hello students, today we'll complete part 2 of extraction of metals and metallurgy unit 6 class 12 science chemistry. One important element plays a significant role in our life, and that is the metals. We get the metals from the earth crust in the form of ore. Then we have to process the ore. We have to apply a complex kind of technique to get the pure form of metal. Now, once we get the ore from the earth crust, we ground it and then we follow the concentration process, that is the physical process. And one important concentration process is your froth flotation process. So this process is very important, and here is some highlight about it. So this froth flotation process of concentrating ore is mainly for the metal sulfide ores. Okay, this process is applicable only for the metal sulfide ores. For example, to concentrate the copper pyrite ore, the formula is CuFeS2, or zinc blende ore, the formula is ZnS. So both of these are sulfide ores, sulfur is present there. So metal sulfide ores can be concentrated with the process of froth flotation. Now what happened in the process, see here, in this process we take a solution of powder ore. Okay, we take the ore, then we powder it, then we make a solution, that means in water we make a solution, and the solution is being taken in a beaker. With the help of a stirrer like a fan, we stir the solution and foam form. The foam contain the sulfide ore, which can be collected in a separate beaker. Then if you give it in the sunlight, the foam will vanish and you will get the metal ore. That means the impurities will left behind in the solution and you have collected the metal ore. Okay, you have separated the metal ore. So that is the basic process of the froth flotation. But the process is not so simple. Okay, here what we have done, we have made a solution of the powder ore. With the stirrer we stir it, the foam formed, in the foam the metal ores collected, then we separated the foam with the metal ore, we dried it and we get the metal ore. But in this process some finer steps involved, and we have to understand what is this finer steps are. Now in this process we need to add some frothers. This table is very important, please note down the table. Okay, you can take a screenshot and you can note the table. So at first we add some frothers. Now what is the importance of adding frothers in the process? The frother helps to make the froth. Simply by stirring easily you will not get the foam, so you have to add some agent that will make the foam, and these are called frothers. Example of frothers are pine oil or camphor oil. Any one of this you can add to make the foam. Secondly, you have to add some froth stabilizer. Once the foam or froth form will vanish easily, but you have to increase the lifespan of the froth. So what you need to add some froth stabilizer. Now froth stabilizer can increase the lifespan or life period of the froth or foam. As a froth stabilizer you can use aniline or cresol. Okay, next you have to add some surfactant or collector. What is the importance of the surfactant and collector? It helps in the collection of the froth. Okay, and it also helps the adsorption of ore particle on the surface of the froth. So surfactant help the ore particle to adsorb on the surface of the froth, which can be collected later. As a surfactant you can use sodium ethyl xanthate. Let's understand how it acts. Okay, what is the role of surfactant, how it helps in the adsorption of the ore particle. To understand it, we'll start with the sodium ethyl xanthate structure. Now here you see sodium ethyl xanthate, the surfactant. The structure is C2H5O, C double bond S, then S minus Na plus. This is the structure. Now this part is your non-polar part. Okay, it's a hydrocarbon. You know hydrocarbons are non-polar, and non-polar compounds are what? These are the hydrophobic. So this part C2H5 part is the hydrophobic part of this sodium ethyl xanthate. This ethyl part is hydrophobic, and the other part is polar, because here you can see the plus minus charge. So if there is plus minus charge, two poles are there, that is the polar part of the compound, and if it is polar, the part must be hydrophilic. So in sodium ethyl xanthate we got a hydrophobic part and we get a hydrophilic part. Okay, hydrophobic part I have designated with a zigzag or wave form, and the polar part with a straight line. Okay, here is the representation. Now metal sulfide ores are polar in nature. Metals are polar, so metal sulfide ores are also polar in nature. Mn plus and S2 minus is there, so it is polar in nature. Now since it is polar, it will be easily get soluble in water. Okay, because water is also polar. We have taken the solution of metal sulfide ore earlier in the beaker and it was water soluble. Since it is polar, this will also get attached with the hydrophilic, because polar get dissolved in polar, polar like polar, non-polar like non-polar, like dissolve like that we have a meet. So what happened here, the metal sulfide ores will get attached to the hydrophilic part, that means with this part the ore will get attached. So it will form a figure like this. Okay, it will form a structure like this. Now once you get such structure, you see hydrophilic part get penetrated in the ore and hydrophobic part is surrounding. Like a micelle, it will form a structure, but as a whole the whole structure now become hydrophobic, because the ore molecule is trapped inside, and as a whole the structure is forming a hydrophobic kind, because hydrophobic part is outside. So ore being hydrophilic get trapped and it is the part of a hydrophobic big molecule now. So if it is hydrophobic, it will be water repellent, water insoluble. So ore was earlier water soluble, but after combining with the surfactant, it makes such a structure that it become hydrophobic. Hydrophobic means water repellent, and since it is water repellent, it will come on the surface. So what happened, the sodium ethyl xanthate make such a mechanism, or it creates such a mechanism that it made the ore a hydrophobic. It turned the ore to be hydrophobic and it will be collected on the surface. Thus it acts like a collector or surfactant, that means it bring the ore to the surface. Okay, next you have to add in the process depressant or activating agent. Okay, now what is the use of this depressant and activating agent? It can decrease. If it is depressant, it will decrease, and if it is activating agent, it will increase the floating of ore particle. Okay, it will enhance the floating of ore particle if it is activating agent, or it will decrease the floating of ore particle if it is depressant. Example is NaCl. Depressant is NaCl and activating agent is your CuSO4. Now let's see how it works. So depressant and activating agent, NaCN and CuSO4. Okay, important, NaCN and CuSO4 combination. Suppose you have taken the sulfide ore, okay, and it have a mixture of zinc sulfide and lead sulfide. That means mixture of sulfide ores. Now out of this, zinc sulfide is your impurity. The percentage of zinc sulfide is less in the mixture. Anything that is less in amount can be treated as an impurity. So suppose zinc sulfide is less and it's your impurity. Okay. Now both of these are sulfide process, so phosphorylation will be applicable to this. Now if both are coming together, then your process is of no use. Okay, you need only one ore. You have to separate the ore. So in this process what we do, we treat this zinc sulfide or the mixture with NaCN. Okay, NaCN is your depressant, sodium cyanide is your depressant. Now with aqueous sodium cyanide, zinc sulfide will react and will form a complex ZnCN4 2 minus. This complex it will form, which is soluble in water. Okay, and it won't float on the surface. So you have taken the mixture, you are doing the froth flotation process. If you are adding NaCN, then your zinc sulfide will remain soluble in the water and your PBS will come in the form of froth which can be collected. Okay, after all the PBS being collected, then what you will do, you will add some copper sulfate. Okay, copper sulfate is your activating agent. As soon as you are adding this copper sulfate, it will form zinc sulfide. Then again you do the froth flotation process. This time your zinc sulfide will come. So if you are taken a mixture, then one sulfide ore you will collect first and then the remaining sulfide ore of the metal you will collect. So for this what you need the depressant and activating agent. For the example, NaCN and CuSO4. So that's how it works. So these are some important part of your froth flotation process. Here it will be Cn. Okay, it's not Cl. It will be a Cn. Okay, you'll correct this part. So this table is important. You'll go through the table. So that's all important part about your froth flotation process. Hope it is clear to you. Thank you.